what's called an interface in Java. It just specifies what kinds of operations are supported by this data structure or this object. So those will be things like getting the ith element and setting the ith element and adding things to the end. So it says what kind of operations are supported, but it doesn't really talk about how they're implemented. And so when I create a new list, I have to specify, exactly what kind of list I want. And you'll see there's several implementations of lists in Java. Well, there's two major ones, which are array list and linked list. And the ones that are most like what we have in Python are array lists. So this creates a new list, it's a new array list, and we'll call it A. Okay. So we can print that. Of course, I already used A, so we're not looking at arrays so much today. So this looks a little bit more like what we're used to. We created a new list, and when we printed it, we just got these square braces, which is, is basically saying it's an empty list. The square braces denote the list. We can add things to this. And each thing that we add gets added to the end of the list. So 45 was the first thing we added, and then 32 was added to the end of that list, and so on. So for example, one of the things that we did last class was to write this range function. Which is something we have in Python. And, well, the way we did it last class was we had it return an array, but we could also have it return a list of these integers. So we start with creating a new list, and then we count for I equals 0. As long as I is less than n, increment I, and add I to the end of this list. So let's say A is just equal to range 10. So it says there's an error. It's a missing return statement on line 11. This is line 11, and of course there is a missing return statement. We're supposed to return a list here. So just to hammer this in again, this is a public function. It means anybody can use it. It's static. It means it's not really part of an object. You can just call it without having any object. And then this is the return value. So it says this function returns a list of integers, then it's the name of the function and the arguments that it takes. And so it's funny, when I started teaching this class, I couldn't stop putting semicolons at the end of every line in Python, and now I can't put them at the end of every line in Java. So we create this range 10, which is 0 through 9, with this function that we just wrote. Print that. add 45 and add 32, they get added to the end of the list. And lists have a well, what are the main things that you do with lists in Python? Well, in Python you do things like a at 2 is equal to 56. Does that work in Java? You'll say that it won't, and you would be right. So it says an array was required, but a list of integers was found. And in Java, arrays are the only things that you can use this index notation on. And so lists are not arrays, so that you can't do this. But that's just a change of notation. So instead of saying a at 2 equals 56, lists have a method called set, and you say a set 2 comma 56. So set the element at position 2 to have value 56. And I forgot a semicolon. Right, so the element at position 2, 0, 1, 2 gets now set to the value 56. And of course, you can't do something like this. That's also not allowed. Instead, you say a.get 11. So in the comments, I'll write something that looks a little bit like the Python code for doing the same thing. Yeah. So the 11th element of this list is 32, as you expect. So these things are indexed starting at 0 and up to the length minus 1. If you want to know the length of a list, that's a.size. And that's equivalent to, in Python, asking for the length of a. Okay, so you can look at specific elements, you can change specific values, you can add to the end of the list. What other things can you do on lists in Python that you might want to do here? Yep. Add two together? Yeah, that's not that simple. I mean, well, okay. So let's add two together. So let's say it's not that it's difficult, but it's not one operation. So let's take a range of 5. So b is the integers 0 through 4. And now you want to add a and b. So what does that mean exactly? You want... Okay, so you want to change a? So that's not exactly what happens when you add two lists together in Python. It doesn't change either of the two lists. But sure. Okay, so let's then say we copy a, and in that copy we add everything that's in b. Let's see if that works. can't find symbol, copy. So since we can't do that, we'll do wow. Do you want me to do it fast or slow? And that won't do it either. I really have to save this thing in a variable. All right. So I create a new list, TMP. It's an array list also. To TMP, I add everything that's in A, and then I add everything that's in B. And so the end result of that is basically what in Python looks like A plus B. Let's check that. Yeah. So there's A, there's B, and there's TMP. Okay, is that clear? It's just it's doing the same things, just slowly, or in a much more wordy way. What else do we do with lists? Sometimes we search through them. So sometimes we look for an element in a list. So for example, we can do that here. So there's a method in lists called indexOf, which looks through the list, looking for the first occurrence of this value that you specify. So let's say, for example, index of 56. What's the answer? No semicolon. Indeed, the index of 56 is 2. And if I ask for the index of 4, what's the answer? So there's a 4, and there's a 4. So index of, we can check. It actually searches from the beginning and goes to the end. And I believe there's also a last index of. And that searches from the end and works backwards. So it gives you the last index that's equal to 4, or the first index that's equal to 4.
Is there an alt index of?
No, not that I'm fairly certain there's not. Okay, so you can search for things in lists. And I think in Python that's what we had, right? In a list, there's a method called index that gives you the index of some element. And maybe there's even an R index, which would give you the same thing as last index of. But okay, so a couple of things to point out. Something we learned at some point is you shouldn't do these very often. So you shouldn't rely on searching through a list using index to find some elements. If you really need to do that frequently, you shouldn't be using a list. You should be using something else, either a dictionary or a set. So I'll just leave a note there that says these things are slow because they really go through the list looking through one element at a time. Okay, so what else do we do with lists? We delete things out of lists. So we can do that as well. And so lists have a method called remove in Java, which lets you remove a particular index. So for example, let's remove 2 and print TMP again. Yeah, okay. So this was the list TMP, and then we removed 2, and this became the list TMP. So 56 disappeared, and the rest of the list closed up all around it. So, you know, now 3 and 1 became adjacent in the list. 56 just went away. Again, this is expensive unless you're deleting near the end. Near the beginning, it's not good at all. Near the beginning is about the worst thing that can happen. So the way to think of it is these lists are really arrays. They're some kind of arrays. And so when you delete something near the front of the array, that means all the other elements have to move back one position to fill in that space. So they get all packed in. And that means they all have to move. It's not bad if you delete near the end, then nothing really happens. You just mark this thing as deleted, or you change a counter somewhere that says don't count that element anymore. But it's expensive to delete near the front. On the same side, you can also add at a specific index. The same thing applies. Oh, forgot to print it. So at index 5, we added 899, and that really adds it. Doesn't change what was there. It pushes the rest of them down. So the same things apply. This is expensive if you add near the front because all of these elements, 5 to the end, had to get shifted over by one position to make room for 899 in this case. It's not so bad if you add near the end. In fact, it's not bad at all if you add right at the end, after the end. Yeah, so just keep that in mind. Well, let's say what was something that was there's actually something really powerful in Python. What's that? Sort. So we might want to sort a list. And well, the way to do that is actually, it's not a routine that's built into lists. It's a routine that's built into another class called collections. Yes. Java.util.collections. So you can collections.sort TMP, and just like in Python, this sort is a destructive operation. It actually changes the order of elements inside the list. It doesn't give you a new sorted list. So there was the list before we sorted it, and there it is after sorting. It's exactly, it sorts in the default order you would expect. There's a way to change that by specifying a different different comparator. But yep.
Is this using just merge sort like we did before? So it's going to be
Collection sort uses a fast sorting routine, and I think the one that it uses actually may depend on what kind of list you have. So it may be using quick sort to do this kind of list. For other kinds of lists, it may use merge sort. So if you look in collections, there we go. It doesn't matter now. So if you look in the collections class in Java, so important, there's two classes. One is called collections. There's another one called collection. They're not the same thing. It can be a source of frustration. There's a bunch of different things in here. So you can get the minimum value in a collection, the maximum value. You can reverse, shuffle, sort, swap. So you take a look at a couple of those. Reverse, shuffle, so we sorted it, then we reversed it, and then we shuffled it so it's unsorted again. Okay. Anything else that we do with Python lists that's useful? Slicing. So what's slicing again?
splitting it into two.
No. Yeah.
Isn't that when you put an element halfway through the list or something?
That's this. It's when we do this indexing where we do something like this, where we do an indexing that looks like A at I up to J. So we get a sublist from I up to J. And so let's look, for example, at the sublists from 5 through 10. And this will be the sublist that has the indices 5, 6, 7, 8, 9. So there's our most recent version of the list, and then we look at 5 through 10. That's these indices, and we pull those out as a sublist. Okay. So that's this is the same thing as doing print TMP at 5 to 10 in Python. But I'd like to look at this in a little bit more detail. So let's say list integer, let's say TMP2. So nothing will change there really if I print TMP2 instead. But let's, for example, change a value in TMP2. We'll set the second element to be something that stands out. So nothing too surprising. There's our list. There's this sublist, and then we change the second value in the sublist. But the maybe a surprise for some of you, comes when we do this. Oops. So what's the surprise here? Changed it in two different lists. So here's our original list, and then we take this little sublist of it from 32 from here to here. Now we just changed the sublist, but actually that also changed the original list. Okay, so this is a choice in the sublist function in Java, that they wanted this function to be really efficient, and it is. It doesn't matter how big the list is how big the sublist is that you take, this function returns quickly. And the reason it does that is because it's not really copying anything or doing anything fancy. It's just remembering the original list and this pair of indices. And now when you access elements in this sublist, it just does some calculations to put you back into the right position in the original list. So the sublist and the original list still share the same thing. So for example, just to be really clear. Yep.
So does that mean that if you wanted to add or remove an item from the beginning of a list, you could make it more efficient by first taking a sublist and just doing the operation on the sublist?
Nope. There's no free meals that way. So for example, here's our list TMP. So back to our little box notation. So we have this little box called TMP that points to a list object, and that list object contains a bunch of things, but it also contains this a pointer to this array here. And then we have TMP2, which is again this little box that points to some list object. And inside that list object, there's a pointer into this array here. And so that's really what's happening when you change the 0th element in TMP2. Well, you're changing this value, which happens to be the 5th element in TMP. So those two things are sharing the same array. So changes in one appear in the other. If you don't want that, you can still take a slice and then copy it. But that's a little bit more work. We saw how to do that up here. So you create a new thing and add everything in the sublist to it. Maybe I'll just illustrate that. So if you don't want this behavior of the two things sharing the same list, you create a new list and then add everything in the sublist to it. Then you really get separate copies. Okay, great. So that's lists, and pretty much everything you can do with Python lists are also available, and the efficiencies are about the same. The only major difference is is with this slicing or this sublist thing. In Python, you actually get a copy of all the elements in the sublist. In Java, you just get basically a shared sublist, which can cause you some issues. So careful. Let's say sort of like or it's kind of like that, and the kind of like means it's not really a copy. Okay, so other things we have, other data structures that are really an integral part of Python, but in Java they're outside support. Well, we saw two other ones, and we saw that they're really useful. So sets and dictionaries were these two other ones. So those also exist in Java, and not surprisingly, they're called sets and dictionaries. So let's look at how we make a set. And this time, let's make it a set of strings. So I want a set of strings. So let's call it, can't call it S, let's just call it set, lowercase, is equal to new. And again, I can't just say set here, because set is really just a definition of what kind of operations are supported, but not how they're done. And so when I'm creating a new one of these things, I have to specify, well, how is it that I want this set to work internally? And the answer is I want what's called a hash set. So it's a set based on a hash table. Now, of course, that won't work until I import set and import hash set. So there I've created this new set and added the string hello, added the string world, and added the string goodbye. So what's going to print? So when the set prints, it says goodbye, world, hello. That's not really a reliable ordering. It's just in some order, because these are sets the same way Python sets are sets, and it follows the mathematical definition of set, which is that it's an unordered collection of distinct elements. So in particular, if I try and add hello again, doesn't change at all. I don't get to add hello more than once. It only shows up in the set once. Okay. So what is the thing that sets are fast for? Searching. And searching means what exactly? Trying to see if something is in there. So print line. Does it contain hello? Does it contain a friend? True, it contains hello. False, it contains friend. So you can just ask if a set contains something, and you get an answer this way. So just using that, we actually did some work last time, where just using sets we got to play around a little bit, and we can go back and let's create a string array, and let's say let's try that. So that's an array of words. And let's turn that into a list. I'm not sure if this will work. Let's see. So we get a bunch of errors starting from the top. The first one says it can't find symbol, and that's because there's a spelling mistake. This should be snarfit. And it says there's no suitable method found for add all string square braces. So it's telling me it doesn't know how to add an array of strings to a list, and the options are collection, whatever. So there's a few ways to deal with that. We could convert words into a collection, but let's just practice iteration again. Words. Okay. So it seems to work. Anybody notice anything weird with these two lines of code? So it's a for statement which iterates through all of for everything in words, it assigns the variable word. There's no brackets. So it doesn't look weird at all in Python to a Python programmer, but what about to you guys? No curly brackets. How come? Yeah. So I said all of these blocks are denoted by curly braces, so indentation doesn't matter. Well, if you only have a one-line block, you can get away without putting curly braces around it. But then don't do something like this. And think it's going to work. Right. So what will happen here? Yeah, word won't be found because word is a local variable to this loop, and this thing is actually outside the loop. Right, Java doesn't care about indentation, and this thing is just having that one line there is the same as if I had just put braces around that one line. All right, so now we've got this big word list. Let's take a look at the beginning of it. Maybe we'll look at the first 50 words. Maybe we'll also print the length to figure out how much we're we'll just comment this part out. Not subset, sub list. Okay, so the first 50 words are an empty word, the project, Gutenberg, ebook of Varney the Vampire. So we got all the words. Looks like they were split reasonably nicely. With the exception of this one empty word here, but won't worry about that. But if we want to do anything useful, we'll want to convert these to lowercase. And I think in Java you use two lower. Can't find symbol. So always, Google is always your friend for these things. Look up the string class, search for lower, two lowercase. Yeah. What's that? Question? Nope. Two lowercase. Yeah. So it can't find the symbol too lower in the class string. So that means there's some name that you're asking for, symbol that you're asking for. In this case, it's too lower, and it can't find it where it's looking for it, which is in the class string. So, and that's because this function, snarfit, returns a string, and so here it's looking for two lowercase in the string class. Okay, that's better. So now everything's to lowercase. Well, so now we did this experiment. 339,000 words in this book. How many unique words? Well, we can say, let's create a word set. We'll take all those words and add them to the word set. So everything that's in our word list we'll add to the word set and print the size of that. Anybody remember what that number was, roughly? 12,000. So 400,000 words and about 12,000 different words. So not a bad vocabulary for this author. Okay, what other kinds of, so that basically gets you the size. What other kinds of questions did we answer with this?
The number of the
So a set won't give that to us. For that we need something stronger. We need a dictionary or a map. So we can do that. But what's, some silly thing? So one of the things we looked for was what were called anonyms. And so for each word in the word set, we look to see if that set also contains that word, and now we have to, that word reversed, right? And then if it does, we'll, let's say, print it. Now, I don't think that word that reverse is the right thing, but we'll try it. Yeah, of course. Oh no. Yeah, so again, can't find symbol reverse. Let's see if and of course reverse doesn't occur. What's that? Inverse? No, that won't be there either. Let's quickly figure out Java reverse string. Here's 3 ways to reverse a string in Java. I just need one. Let's take this one. And a string buffer in IO or lang. So actually I don't think I need to do anything with it. At the top? Non-static method. Okay. Looks like we've got this working. So it looks like there's a fair number of these things. Some of them are kind of boring. So the empty string is, of course, an anonym of itself. Anything which is a palindrome, of course, is also an anonym. But meet and team, the team as in teaming with, all the numbers, of course, are palindromes. Mead and Deem, F, G, D, somewhere these things occur, probably in chapter headings. Draw and Ward, Snug and Guns, Ward and Draw, Stop and Potts, Star and Rats, God and Dog, Me and M, Am and Ma, Ah and Ha, Aha, No and On, 3 and 3, Doom and Mood. So lots of these things. Hoop and Poo, Tub and Butt, Peep and Peep, Dawn and Nod, Lake and Ecal. That I don't know what Ecal means. Tip and Pit, Did and Did. So lots of interesting ones there. Guns and Snug, that's an interesting pair. Okay. All right. So that's one of the things we can use this for. And now the same sort of things are true. So word, remember, there's 12,000 words in the word set, and even worse, in the word list is much bigger. There's 330,000, and so it's important that we use a set here, or it's very helpful that we use a set here, because we're able to check if the reverse is in the set very, very quickly in this line right here. If you didn't use a set, well, for example, if you used a list, then it would be much slower, so we can try that. Well, let's just iterate over the words in the set and then use the list to see if it's contained. See if that... So you see that this part is actually taking time. Whereas before this was instantaneous. Yeah. So definitely better to use the. It's definitely helpful to have the set here. Okay. All right. So one of the other things we did was to look at, well, how varied things were, or what were the most frequent words that were used by this author, or the frequency of words used by this author. And for that, we used what's called a dictionary in Python, and what's called a map in Java. So a map is this thing, remember, that takes keys and maps them onto values. So lists were a little bit like this in that they take integers and associate them with values. Maps can take any kind of key, not just integers. And so let's see how those work in Java. So we want a map. And if we're interested in counting, so maps have two objects or kinds of objects associated with them. The kinds of the keys and the kinds of the values. So if we want to keep track, for example, how often every different word occurs, then what are the keys that we're going to use in our map? The words. And what are words? Strings. And then what are the values? No, they're not going to be more than 2 billion. So integer will do the trick. And more importantly, even if they weren't, we could use long. But more importantly, the values that the counts, they count the number of occurrences. So they really are integers right there. There's no need for floating points or fractions. And again, map is just what's called an interface. It only tells us what the operations are that the data structure supports. It doesn't tell us how they work. If we're going to create a new one, we have to say exactly how we want it to work, and the one we'll use is a hash map. Okay. Oh, then we have to give this thing a name. Let's call this the word map. So just to see that we're using this right, we haven't forgotten. Okay, so I create this word map, and just to start with the, I associate 100,000 within 8,000 something, where 2323, and we print it out, and we see we get something similar to what we get when we display a dictionary in Python. These pairs of values, string associated with an integer, string associated with an integer. Okay. Now, anybody remember how we then got this frequency count? So we have this list of words that's in our book. How do we do this frequency counting?
Wasn't there a function that was like count?
Dot count is not a great way to do it. Slow, because you'd have to call dot count for every different word, which means then, and dot count just goes through in a list looking at every element. So how do you do that when you have a list and you have a map? How do you count the number of occurrences of every distinct word in that list? So you've done this on an assignment. Yep. Yeah. So if our word map contains the word, already contains the word we're looking for, and in fact it contains key, then that's great. Otherwise we have to do something else. So if it doesn't contain the word we're looking for, then we want to add that word, which in maps means we want to put something there. And with that word, we want to put the counter 1. It's the first time we've ever seen this word, so we'll say it occurs once. And otherwise, we also want to put something, but it's something different. So with word, we want to associate the value that used to be there plus 1. Okay. and, well, let's just print it. See what that gives us. Okay, so there we get a list of, well, we know it's 12,000 words, and we see how often they were, each word occurs. Spectre occurs 3 times, mob 204 times, disaster 5 times. So there we get our list of these things. That useful?
Is that in order of which it occurs?
What's that?
Is this in order of which all occurs in the book, or is it?
No, this is just printing out the word map. And maps are kind of, well, actually the keys associated with a map are a set, because each key can only occur once. And actually they're like a set also in the sense that they're not in any particular order. So this is just printing them out in whatever order they happen to show up in the map. But we can, I don't know, we can try a few other experiments. For example,
How many times a certain word occurs?
yeah, I mean, we can look at, you know, a few words, the more common ones maybe from the beginning. So for example, word in list. Let's take a sample out of the middle of the book. I don't know, from 3,000 up to 3,050. So there's, I mean, this is something we can read, and we can see how often some of these more common words occur. Thinks 16 times, then 1,216 times, of 9,500 times, the 17,000 times, storm 41, surely, produce. And there was one surprising thing in there that I remember from last class, which was, this is a, we can look for some of the words that were that you might expect to see. For example, vampire. Although there might be a weird spelling issue. And the one that I thought was surprising was blood. So vampire occurs 22 times only in this book, this enormously long book. Blood 117 times. I guess they don't use the other spelling. Okay, so now you certainly know everything you need to do all of the assignment.